Okay, so now we will study cascaded counter. Cascaded counter is used to improve the timer interval of a clock. For instance, let's assume that we have an 8-bit counter. 8-bit counter. This counter can count from 0 to 55. Let's assume that the clock interval is 10 nanosecond. So it can count from minimum to 0 to 2550 nanosecond. So the minimum interval is 0, the maximum interval is 2.55 microsecond. So this counter is capable to count from 0 to 2.55 microsecond. But if we want to have an interval of, for instance, we want to have an interval of 25 microsecond, how we can achieve this? So we cannot achieve this with an 8-bit counter. So in this particular scenario, what we can use? We can divide it into two parts. We can use two 8-bit counter and connect them in a cascaded fashion. So for instance, this counter will count from 0 to 2.55. So we can initialize the counter. This initialize the counter. This will count from 0 to 255. So it will count from 0 to 255. At this point, the top signal will be 1. So now we have a clock. So let's assume this is the clock. And if the first counter, let's assume this is the first counter, let's reset. This counter is reset. So to count 1, so this is the count 1. This will be the value of count 1. Count 1 will be 0. And at this point, count 1 will be 1. And so far, so on. So when it reaches 255, when it reaches a count of 255, the top signal will be asserted. The top signal initial will be 0, and then it will be asserted for 1 clock duration. For 1 clock duration. So this second counter will count that how many times the first, this counter is stage 1 counter, and this counter is stage 2 counter. So the stage 2 counter will count the number of times this counter is overflowed. So for in this example, so the top signal will be asserted for 1. So in this case, count 2 will be 0 at this point. Let's assume they are both reset at the same time. So count 2 will be 1. Again, the first counter will be initialized to 0. After reaching 255, the first counter will be initialized to 0. And when it again reaches 255, this will be 0, 1, 2. So let's assume that the value of count 2, the value of count 2 is 30. The value of count 1 is 200. So what is the total time duration? So the total time duration so count 2 is 30 and it counts an interval of each interval of 2.55 microsecond. And the first counter, that's the count 1. Let's assume the count is 200 and it counts an interval of 10 nanoseconds. So this will be equivalent to 2.55 multiplied by 30. 7612 76.50 microsecond plus this will be equivalent to 2000 nanosecond. It will be equal to 2 microsecond. So the total duration will now be 78.50 microsecond. So now you can consider this like in a stopwatch, or in a stopwatch we have different digits. So let's assume these are digits. This is a second digit. Then there is a minute digits. The second digits will count from 0 to 59. When it reaches its value, that's 60. So this when it's 59 at 00. So the next value will be, the second digit will be reset, and the minute counter will be incremented. Similarly, when the second reaches again to 59, the minutes counter will become 2 and it will be again reset. So stage 1 is counting at the final granularity. That's the granularity of this clock. Let's assume the clock period is 10 nanosecond. So it is counting at a granularity. So the counter counter 1 is counting at a granularity of 10 nanosecond, because each clock's period is 10 nanosecond, and counter 2 is counting at a granularity of, when this counter will reach its maximum value. So this counter will reach its maximum value when the count is 255 multiplied by 10. So this is equal to nanosecond. This is equal to 2550 nanosecond, and this is equal to 2.55 microsecond. So the second stage counter is counting at a granularity of 2.55 microsecond. So if it's 1, so it will be 2.55. If it is 1, it will be 2.55. If the count is 2 for counter 2, so it will be 2.55 multiplied by 2, because it's step of 2. If it is 3, the count is 3, it will be 2.55 multiplied by 3. Similarly, this count 1 is counting at a granularity of 10 nanoseconds. So if the count is 1, it will count at a granularity of 10 nanoseconds. If it is 2, so 2 multiplied by 10 nanoseconds, that is 20 nanosecond, and 3, 30 nanosecond. If the count is 4, it will be 4 nanosecond. And it reaches the maximum value, that is 255. The maximum value is 255. So 255 multiplied by 10 is 2550 nanosecond, and this is equivalent to 2.55 microsecond. So it means that the cascaded counters are used when we want to count for a large time interval, because this counter is only capable to a maximum of 2.55 microsecond. So this is counting at the final granularity, a shorter time interval, and this is used at a larger granularity or a coarser time interval. We can also So now let's assume that if we cascade two 16-bit counters, so if we are using a counter of 16-bit counter, this is your clock, reset, this is count 1, and this is a top signal. The top signal will be asserted when it reaches its maximum value. And now if we have another 16-bit counter, so this count 1 is connected to the clock of the stage 2, sorry, not count 1, but this top is connected to the signal of, and this is count 2. So what is the granularity of this counter? The granularity of this counter, let's assume if the clock is 10 nanosecond, so the granularity of one count is 10 nanosecond. So if the count is 5, so the granularity is 5 multiplied by 10 nanosecond, so it is 5 nanosecond. So let's assume, so this count, let's assume if the count of this counter 1 is 5 and the counter of this count is 10. So what is the total time duration? Time. The count is 5. The granularity is 10 nanosecond. Plus, what is the count for this counter? Let's assume 10. And what is the granularity? The granularity is when it reaches the maximum value. The maximum value, it will reach the maximum value when it reaches the count of 5535 multiplied by 10 nanosecond. So the total time is now 15 nanosecond plus, this is the count, this is the maximum value when it reaches the maximum value, so it is 6553500. So the total time will be now 6553550 nanosecond. You can convert it into microsecond or millisecond if you want. Now prescaler. A prescaler divides clock and it increases the range and decreasing resolution. I will explain this with the example. So now let's assume this is a prescaler. Prescaler, there is a mode for prescaler. I will also explain the mode. And now we have a clock. So it will give us, it will calculating the clock. So 16-bit counter. This is your count. And now reset and the top signal. This 16-bit counter will count from 0 to 65535. So if the clock is 10 nanoseconds, so there can be different modes of operation. So if the mode, let's assume that this mode is 2-bit signal. So this is 00, the 01, 10, 1 1. If the mode is 0 0, it will use the clock. The clock means that now if the duration is 10 nanoseconds, so the mode is, so there are different modes of the clock. So the mode, let's assume this is the mode, and now we have 0, this is 1, this is 2, this is 3. So if it's the mode is 0 0, it will use the clock duration of 10 nanosecond. If the mode is 1, it will use a clock duration of 20 nanosecond. It means it will divide the clock by 2. If you use a mode of 2, it will use a duration of 14 nanosecond. It means it will divide the clock by 4. And if it's 3, then it will use a duration of 8 nanosecond. It will divide the clock by 8. I will explain this with an example how the clock is divided. So now let's assume that you have a clock like this. And now this is your clock. And in this case, this is clock input. So this is clock input in mode 0 0. So in mode 0 0, it will use the same clock. It will use the same clock. And the clock input in mode 0 1, mode 0 1, mode 1, clock input. So the clock input in mode 1, it will divide the clock by 2. So it means that now you have high time. So now this duration is 10 nanosecond in mode 0. Divide the clock by 2. So it means now the clock duration will be 20 nanosecond. And clock input in mode 2, it will use a clock of 14 nanosecond. So now the duration is, this duration is 14 nanosecond. So in mode 1, we are using the clock as normal. In mode 2, we are increasing the duration of the clock period. So the clock period is now increased. So in this case, we have a high resolution. And in this case, we have a low resolution. And the resolution is lowest. But if we calculate the range of the counter, so it increases the range. So let's assume that now we will do some examples. What will be the final time interval? The final time interval when count is equal to 30 in mode 1 and mode 3. So in mode 1, the count is 30, so the time in mode 1 is count multiplied by clock period. The count is 30. The clock period is 20 nanosecond. So the delay is 600 nanosecond. What will be the time in mode 3 for the same count? We are not increasing the count, we are using the same count. So what is count? Count is 30. And in mode 3, what is the clock period? 80 nanosecond. So if we multiply this, so it will be 2400 nanosecond.